Good day, good day, good day. This is video number 2 of vertical projectile motion. We are sketching the graph for the objects thrown vertical upwards. So we are going to sketch the graph. So we have how many graphs? We have graph number 1, that is position versus time. Okay, that is position versus time. Then we have velocity versus time. Then we have acceleration time graph. So it's acceleration versus time. Okay, so let's go straight. Remember, we defined free fall and a projectile. We said the projectile is an object which has been given an initial velocity and then it moves under the influence of gravity or gravitational force only. The free fall is the motion during which the only force acting on an object is the gravitational force. Okay, so we are going to draw graphs. Graph number 1, it's a position versus time graph. Position time graph. Okay, then number 2, we are going to draw the velocity time graph. Velocity time graph. Then number 3 is acceleration time graph. Acceleration versus time. Okay, remember we have equation of motion. Then we have number 1, it was a final velocity which is equal to the initial velocity plus a delta t. Now if you can look at this equation, we have no another degree, that is squared. So we have 1 1 1 1. Here in time we have 1 as exponent, which means this one is a linear function, is a linear graph. So if this is the linear function, now if you can look here, we have velocity, acceleration and time, which means this simply means that any graph that has to do with velocity and time is linear, acceleration and time is linear, because this is a linear graph. So this one is a line graph, that is linear function, and this one is also a line graph, a straight line, that is a linear. That is y is equal to mx plus c. Mx plus c. Y is equal to mx plus c. Okay, then we have equation number 2, which is final velocity square plus is equal to initial velocity square plus 2a delta y. Now if you can look here, we have the velocity and acceleration but not time, which means this one we cannot use this equation because we have position time graph, velocity time graph, acceleration time graph. It must have 2, not 1. Then we have another equation which says dy is equal to initial velocity delta t plus 1 over 2a delta t squared. Okay, so if you can look at this one has the position, that is delta y, and what, and the time, which means this one is for the position, but there is a square here. Upper kwixesha there is a square, which means this one is parabolic. It's parabolic function. So this one is parabolic function, which means position time graph will be a parabola, or we can say a curve. So it's parabolic. Okay, so we have this information now that the position time graph is parabolic. the velocity time graph is linear, the acceleration is linear. Okay, so we are going to start with the position time graph. Okay, let's take an example of a stone that was thrown vertical upwards, an example of a stone that was thrown vertical upwards. So position versus time, position, time graph. So the stone is thrown from here upwards, then back to the thrower's hands. So it was moving at 10 meters per second upwards. So we know that here the velocity is 0, then here is also 10, but downwards. Okay, then if you still remember, we have 5,10 here meters in that video, but we can also calculate it using equation of motion. Even here it's 5,10 meters. The time here was 1,02 on video number 1 seconds. The time here was 1,02 seconds. Okay, then this one we said it is parabolic function, so which means the graph will be like this. So it is very simple because we are going to just copy this one, then we are done. So the position time graph is having axis, that is the y-axis and the x-axis. On the x-axis we are going to have delta t always. On the x-axis we are going to have delta t always. Since it is position time graph, therefore on the y-axis we are going to have position. So this is position delta y in what? In meters, the position. Then this is the 0 position, that is the starting point in this case. If they said make the ground the 0 reference, which means upper go 0 meters, here 0 meters, then from here to here it's 5 meters, from here to here is 10 meters. Okay, so make the starting point as your 0 reference, make the ground as a 0 reference. You just copy like this. That is the position time graph, because we said it's parabolic. It's very simple. So here you must know that here the distance is 5, the displacement is 5,10 meters. Then the time for this part, the first path, is 1,02. Then for the whole path is 2,04 seconds. That is the position time graph. We are done with it. The ground is our 0 reference. That is done. Position time graph is parabolic. You just copy it. 0 reference. So you draw the graph here. Then we have 0 here. Then you copy. Okay. Then let's go to graph number 2. That is velocity time graph. Velocity time graph. Velocity versus what? Time graph. So it also have the axis, we have the y-axis and the x-axis. Trying to draw a straight line here. Then so I said always here there is a what? A time in what? In seconds. Now that it is velocity time graph, so here we have a velocity in meters per second. Okay, remember we said this one is linear. It's a line graph, straight line, linear graph. Y is equal to mx plus c. Okay, so this is a 0. We have time, which was 1,02. Then together we have 102,04 seconds. Now, when we are drawing this velocity time graph, I think the best way is to have the coordinates. Remember, the coordinates is x, y, always x, y. Okay, you need to have the coordinates x, y of every point. Now remember, the ball was from here up there, then back to the thrower's hand. So we said the velocity here is 10 but upwards. Then the velocity here is 0. The velocity here is 10 but downwards. So we have 3 points here. We have the starting point, we have the maximum point, we have the ending point. So we have 3 points, which means we have to look for 3 coordinates. Remember, we have x, y. On the y-axis there is v. On the x-axis there is delta t. So we have delta t is 2v. Okay, so the first time is 0. That is the starting point. The time is 0. That is the starting point. The time here is 0. Then the velocity here is 10. And remember that upward is positive, then downward is negative. Okay, so the velocity here is 10, which means we have 0 is to positive 10. That is the first point. The second point is this one here. How many seconds from here to here? To 1,02 seconds. 1,02 seconds. The velocity there is 0. That is maximum point. Once the velocity is 0, you must know that is a maximum point, which means the object was thrown vertical upwards. Okay, then we have this point, the last point. So the time from here to here is 2,04 seconds. So the time is 2,04 seconds. Then the velocity here is minus 10. Now we need to have this on the graph and we plot it. So we have another side here. So we have minus 10 here. That is the speed. Then we have what here? 10. That is the speed. Now let's draw the points. Point number 1. 0 is to 10. X is 0. Okay. Y is 10. So this is the point. That is the first point. Point number 2. X is 1,02. That is x is 1,02. Y is 0. This is the point. Then the last point, x is 2,04. But y is negative 10. So we have another point here. This is important. You must have these dotted lines. So we join the points, then we're done. That is the velocity time graph. We said it's linear. That is linear. Okay, then we're done. Now another thing that you need to know is that once it intersects here, which means it was thrown vertical upwards, this is the maximum point. The y-intercept is the maximum point. The y-intercept is the maximum point. So it was thrown vertical upwards. And if you can look here, the graph is decreasing, which means up was taken as positive, down as negative. Okay, so let's go to the last graph. That is the acceleration time graph. Acceleration time graph. That is the acceleration time graph. versus time. All right, remember we said this one is also linear. Okay, so we have acceleration on the y, meters per square second. Then we have delta t in what? In seconds. And remember we have two delta t 0, 1,02 and 2,04. Then on the acceleration, we said the acceleration here is constant because the object that we're talking about was on free fall. So the acceleration is 9.8. We have positive side here, positive, then here we have negative 9.8. Okay, so you can even here draw you have the coordinates here. Alright, so we have the object like this, moving like that, A, B, C. So the time here is 1,02. The time here, seconds. The time here is 2,04 seconds. Okay, so the acceleration, the time here is 0. The 0 seconds. Then the acceleration here is 9.8, 9.8, 9. Okay. So which simply means that the coordinates will be like this. We have the coordinates that is x, y. So x is always delta t. In this case, y is acceleration. So upper A, the time is 0. The acceleration is 9.8. But downwards, we said downwards must be negative. Then point B here, the time is 1,02. Okay, the acceleration is negative 9,8, which means 9.8 downwards always. Here the time is 2,04. The acceleration is still that 9,8. So we plot these points. Point number 1, 0 is to negative 9.8, which means we have a bullet here. Then point number 2, 1,02 is to minus 9,8. So this is the point here. Another bullet here. So we have the last point at C, 2,04, negative 9, now 2,04 to this point position. So that is, let me just use another color. So that is the acceleration time graph. Then we are done. That is acceleration time graph. So acceleration time graph will be like this. So if you are given acceleration time graph where the acceleration is negative, the graph is drawn from the negative side, you must know that up was positive, down was negative, right? The direction was taken like that. So you must know the acceleration is negative because up was considered to be positive, which means down is negative. But if it is drawn in this side, that is positive side, you must know that down was taken as positive because acceleration is always going downwards. So once the graph is drawn on the positive side, you must know down was taken as positive. Okay, then that is it. So the graph that we draw today is the graph of the object that was thrown vertically upwards. Okay, that was thrown vertically upwards. For an object thrown vertical upwards. Okay, so let's have the position time graph for another object that is thrown from certain height now. Okay, from certain height. Okay, so the object is thrown vertical upwards by 10. We know that the distance from here to here is 5,10. Then we have the height of the building, which is 50. We have the time from here to here, which is 1,02 seconds. But we need the time at C. Let's quickly calculate that. Let's collect the data. We need the time here, so we can use this 10 to here. So we are going to use this 10 to here. Okay, so we have the initial velocity, which is equal to 10 upwards. We're looking for time. We have delta y, which is 50 below the starting point, which means downwards. Then we have acceleration, which is 9,8, always downwards. So we can use formula number 3, delta y, which is equal to initial velocity delta t plus 1/2a delta t squared. Okay, so choose the direction. Upwards is taken as positive, so this one is negative and this one is negative. Now let's substitute. So delta y is negative 50. Initial velocity is positive 10. Delta t is what we are looking for, 1/2. Acceleration is negative 9,8. Delta t is what we are looking for. Okay, so this is quadratic. Where let's press calculator here. So we have minus 50 here, which is then delta t minus negative times positive, negative times positive. It's minus, then 1/2 times 9.8 is 4,9 delta t squared. Now we can rearrange it. So we have minus, we can transpose this one to this side. Okay, so we have minus 4,9 delta t squared. This one is positive, plus 10 delta t. Then this one, when it comes here, it will be positive 50. So we are left with 0 here. Now we can factorize here using quadratic equation. So quadratic equation says, let's assume this one is x, so it's t, which is equal to minus b plus or minus b squared minus 4ac. Everything is divided by 2a. So this one is a. This is our a. This is b. This is c. Okay, now we can just substitute. So we have t, which is equal to minus b. B is 10. Then we choose one sign here. Then we choose plus for now. Then we have 10 squared minus 4 times a is minus 4,9 times c. C is 50. 50, that is 50, right? So everything is divided by 2a. A is 4,9. A is 4,9. 4,9. Then we press calculator here. Then we change sign to negative here. So we get, oh, this one is negative. There is a negative here. There is a negative here. So it's 2 times negative 4,9. Then we get this answer. Then we change the sign. Now let's put minus here. Let's put minus and press calculator. So t is equal to, another t is equal to 4,38 or 37. So This is the correct t. T can never be negative. So the time at C, let me just say C, is 4,37, right? Then we also need the velocity here, but that is not much important. Now let's draw the graphs. The first graph, position time graph, with this information. Okay, position time graph. Position time graph. So we have the y-axis, we have the x-axis. The y-axis is the position, let's just say dy in meters. The x-axis is delta t in what? In seconds. So we have 0 here. So if we use the starting point as the 0 reference, so we are going to draw the graph on the diagram. So this is 0, which means we are going to draw a graph like this. This is 0, which means the graph will pass the x-axis like this one, okay, to -50, because below is -50. So we are going to draw the graph that will be like this, go up, then pass here. Okay, so here is -50. From here to here is 5,10, right? Then we need the time. So the time here to reach the maximum point is 1,02, but the time to reach the ground is 4. This is 1. This is 4,37 seconds. Okay, now if we use the ground as a 0 reference, here the starting point is a 0 reference. Starting is a 0 reference, which means our 0 will be on the starting point. So our 0 will be on the starting point here. Okay, our 0, this is the starting point, that is our 0. But if we use ground as a what? As 0 reference, which means our 0 will be here. This is our 0. Therefore the graph will be like this. So we will have 0 as a ground here. Then after 50 meters, we throw the ball upwards. Then after 50 meters, we throw the ball and it reaches the ground which was our 0. This is our 0 reference. So here is 50. Then here will be 50 plus 5, so it's 55,1. That is the graph. So here is 1,02. Then here is 4, what? Let me go back and check. 4,37. 4,3, and it's 4,37. .37 seconds. So that is how we draw the graph. The 0 reference is the starting point, which means your 0 will be here. This is a Cartesian plane with 0. The ground is a 0 reference, which means here is your 0. Then you draw the graph. Then we are done for this one. We are going to the next video, which is the graph of an object thrown vertically downwards. This one is going straight downwards, so we are going to focus on that. Stay tuned, make sure that you subscribe. Thank you.